You know that feeling when you look up at the sky and see something that just makes you wonder? Something that sparks a question you can't quite shake? Well, today we're diving into one of those big questions, using the sky itself as our clock.
So picture this. Our story starts with a girl named Mira. She's at a kite festival, right? The sky is blue, the sun is out, kites are everywhere, and so is the moon. And seeing it there in broad daylight gets her thinking. She knows it's a giant ball in space, but right now it just looks like a little sliver, and she's seen how it changes shape from night to night. So what's going on? That's the big mystery we're going to unravel together. Why doesn't this giant sphere in space always look like a perfect circle to us down here on Earth? All right, so like any good detective story, before we can solve the puzzle, we need to gather the clues. Our first step is to just watch and see what the moon is actually doing up there. And when we do that, we see something amazing. It's not random at all. It's this beautiful, predictable pattern. It goes from a full, bright circle, shrinks down to nothing, and then grows right back again, all in about a month. It's a perfect cycle. Now, there's a name for these changing shapes, of course, the phases of the moon. And the most important words in that definition are bright portion and as seen from the Earth. That right there, that's our first major clue. So let's walk through that cycle. We start with the full moon, a big, beautiful, bright circle, also known as Purnima. Then, over the next couple of weeks, the light starts to shrink. That's the waning period, or Krishna Paksha. It keeps shrinking until we get to the new moon, or Amavasya, where the moon seems to disappear completely. But then it starts to grow back. That's the waxing period, or Shukla Paksha, which builds for 2 more weeks until we're right back at a full moon. Okay, so we've got our evidence. We know what happens. Now for the big question. Why does it happen? It's time for the aha moment. Now, I know what a lot of you are probably thinking. It's the Earth's shadow, right? The moon moves behind the Earth, our planet blocks the sun, and the shadow cuts a piece out of the moon. It seems totally logical. But is it the real story? Well, not quite. That's a really common idea, and it does describe something that happens. It's called a lunar eclipse, but that's a much rarer event. The real reason for the everyday phases is actually much simpler, and honestly way cooler. It's all about our point of view. Here's the key. The moon doesn't make its own light, you know? It's basically a giant mirror reflecting sunlight. And since the sun is way over there, it can only light up one side of the moon at a time. So no matter what, one half of the moon is always bright, and the other half is always dark. Always. So here it is, the big reveal. It has nothing to do with Earth's shadow. It's all because the moon is orbiting us. As it travels around the Earth, our angle for viewing that sunlit half changes. Sometimes we're looking straight at the lit-up side. That's a full moon. A little while later, we can only see a little sliver of the lit side. That's a crescent. And when the moon is between us and the sun, we're looking at its dark side, so we see nothing at all. That's a new moon. It's not a shadow, it's just perspective. Now, this predictable, reliable cycle isn't just a pretty thing to look at. It's incredibly useful. For thousands of years, people have used this cosmic dance to measure time. It's actually the foundation of our calendar. Think about how precise this is. The entire show, from one full moon all the way to the next one, takes almost exactly 29.5 days. It's a dependable rhythm that has guided civilizations for, well, forever. And that dependable cycle gave us a perfect way to track time. You can almost hear it in the word itself, right? Moonth. That's not a coincidence. This is literally where our concept of the month comes from. We were keeping time with the moon. But here's where things get a little tricky. If you add up 12 of these moon cycles, you get about 354 days. We call that a lunar year. But a solar year, the time it takes for Earth to go around the sun and for the seasons to repeat, that's about 365 days. So the numbers don't quite line up. And that 11-day gap might not sound like a huge deal, but over time, it adds up. It means that if your calendar is based only on the moon, the months slowly drift away from the seasons. Eventually, your summer months would land in the middle of winter. It's been a huge puzzle for calendar makers throughout history. So let's just zoom out for a second and appreciate the big picture. For pretty much all of human history, we've looked to the skies to understand our place in time. It's really this simple and this profound. The Earth's spinning around gives us our day. The moon circling the Earth gives us our month. And the Earth's long journey around the sun gives us our year. Our entire system of keeping time is written in the movements of the stars. And this is not some new idea. People figured this out ages ago. Listen to this ancient verse from the Taittiriya Samhita. It shows that observers thousands of years ago were already tracking these cycles with incredible care.
They called the sun's northward journey Uttarayan and its southward journey Dakshinayan. And this wasn't just some abstract hobby. This was about survival. By tracking the sun's path, they knew when the seasons were changing, when to plant crops, and when to harvest. They were truly living by the sky's schedule.
Which just leaves us with one final thought. We've decoded the secret of the moon's phases, but it makes you wonder, doesn't it? What other amazing secrets are just waiting for us, hidden in plain sight, right above our heads?